We got a few questions came in on TikTok to talk a little bit about trolling motors and trolling motor power options, placement, selection. So here we go. We're going to break this down and we're going to try to make this as simple and easy as possible. And if you ask more questions, we'll go into more detail on it and discuss it in more detail. Number one, trolling motor selection. So let's talk in a bit more detail about trolling motor selection. First, a little bit of disclaimer. Ensure that if you're not comfortable with any of this, go to a boating center, talk to someone, talk to a service center, pick out the right trolling motor for you and installation. If not, if you're looking for a little bit more information, hey, for the trolling motor, you're typically going to go by brand, feature, or integration. You're looking for something that your family's told you about or a feature that is specific to a certain trolling motor that you're looking for as far as functionality, or it comes down to integration. For me, it was a lot about all three of these. I was looking for a specific brand to integrate with my chart plotter as well as future functionality that was built in some of the features. And so this was a really easy decision for me. Power options are going to be pretty simple. Think of volts and amps as far as how they produce electricity for your overall trolling system. Typically, there are 12 volt, 24 volt, and 36 volt systems, and then you'll select some option of amp hours, which depends upon whether you set up your batteries in a series or parallel configuration. Okay, I'm just going to write the word motor here and have it represent the motor connection. There's going to be a positive and there's going to be a negative terminal. Most of the time, you're going to use a breaker in between here as well. So just for the sake of speed, we'll keep this really tight. Okay, so what is unique about parallel? Well, first thing is we're going to connect each of the positive terminals to each other, and then once we've connected them, we're going to connect it to the actual either fuse or directly to the motor. We're going to do the same thing on the negative side. So negative side, same connection. And what we're doing essentially is because we're separating out before we go to the motor, we are keeping the voltage the same and we are amplifying the amp hours. So in this bank of 3 batteries there, we could say, okay, if there's 55 amp hours per battery, then we'd multiply that times 3 and we'd be able to get our total calculation. All right, and if you go to read this on your multimeter, it's going to come out to 38.4, but that is within tolerance. This is a 36 volt system. All right, let's reset and say you are using 12 volt batteries. The setup's going to be the same, but just work with me here so I don't have to reset everything. So 36 volt batteries, you're going to take the positive terminal and connect it to the negative terminals on this series of batteries. And what that's essentially going to do is it's going to amplify the voltage per each battery that you add. If you're looking at 12 volt batteries, you do 3 of them, you get up to 36 volts. This is where you commonly see folks doing this, not with 36 volt batteries. But in my case, I'm using 36 volt batteries. So if we say 36 volts, we've set them up now in a series. So we will multiply the voltage, and this is going to give us, our total here is going to be 108 total volts that will be distributed from this system. These batteries are set up in a series, not in propeller, so they're going to have 55 amp hours in this total system. We don't get to add up those amp hours. Now let's talk about placement of your trolling motor on your boat. It's going to sit on the front of the boat. Then you'll have the shaft that runs down into the water. The propeller is going to be on the end of the shaft, and then you have your water level that runs across like this. So the water level, right, is very important to think about, because if you buy the incorrect length of shaft for your boat and the type of water that you're going to be in, then this is what can happen, and this is when your shaft is too short, and so cavitization happens where that propeller now is coming out of the water as the boat moves on the top. So make sure that you measure 2 things. Measure from the deck of your boat down to the water line, and then if they take into consideration, how rough the water might be that you're in, and then the second measure that you're going to take is going to be from the deck of your boat, or actually the top of the trolling motor down to the propeller, and this is where you're going to be able to, with that measurement, make sure that you're always going to have the propeller in the water and you're buying the right trolling motor. The next thing to think about is placement on the deck of the boat. In this case, I have an anchor bay, we've got a navigation light, we've got a couple of cleats that are on the front, on the port and starboard side. So it's really important to think about how we're going to place this motor so that it doesn't run into any issues. So for example, if I put it on the this side of the boat, then I'm going to run into issues with my anchor and my navigation light. It's going to block even when I open my anchor door here on the right. So the thing that we went with was called a C-swivel. The C-swivel allows me to use a quick mount and mount the trolling motor this way, and then we could then rotate the trolling motor to the right or to the left, right? So I could adjust it to be on the starboard or port side, and because I have a Garmin, I could select which side the trolling motor was on, and then I could stow it on the right or left side, and then just use a rail mount to clip it. So I hope this was helpful and answers a lot of questions.